Hello students, welcome back to another lecture on complex analysis, and hope you are enjoying the previous 4 lectures on complex analysis. And here you can see that today we are going to discuss on continuation of the last class, and today's class happens to be lecture number 5. So the main topic of the interest would be on the calculation of the absolute values, which is the place where we have stopped in the yesterday's class. And just to refresh your memory, I have written down here what happened in the last class, and this has to be remembered like a black box equation. The most important thing that we discussed in the last class is that the modulus, complex modulus, is not distributive. You can see that the product is coming over here with an equality. Okay, when the equality is there, you say that the distributive property is satisfied. But here, if you come here, there is equality is not there. Equality is there only for special case, only for special, other than the special case. In all the cases, it is not equal. That means it is less than. Okay. So therefore, this inequality tells clearly that the complex modulus is not distributive. So that's the place where we stopped. And we need to do one more calculation, and what is known as the reverse triangle inequality. So this equation number 4 is known as the triangle inequality. And if you write down a similar expression in a similar style, but there is a minus there, then the equation is known as the reverse triangle inequality. Okay, if you can complete equation number 5, then we are ready to solve the problems. So today what we will do is we will quickly obtain this reverse triangle inequality and then take up some example problems. So today's aim is clear, right? So let us start with the reverse triangle inequality. Idea is like this. So what do you suppose if you have only one complex number z1? I have only one complex number, but you can write down in the other way using two complex numbers. It's like this. So I have z1 plus z2. So it's clear that I can always subtract and add the same complex number. So I get the original here. That's an idea. And then what you do is you apply equation number 4, which you have it there. Okay. So what is the triangle inequality here? So this is the one that we are going to use this. So apply this rule now. So apply this equation number 4. So first you write this, apply equation 4, which is nothing but the triangle inequality. So then what happens is this equality will become less than or equal to. And then these are two complex numbers, so I can write down modulus of z1 plus z2. And then you have plus modulus of minus z2. Right? So z1 plus z2 is a complex number. Then minus z2 is a separate complex number. So I can actually write down plus of minus. Okay. So which is nothing but, so how do you write this? This is z1 plus z2. And plus the modulus of the negative is nothing but the modulus of the positive. So this minus will not do anything. Therefore I will get back the mod z2. So you understand that mod z2 is same as mod of minus z2. So once you are taking absolute value, this minus will not affect the calculation. This is one way to understand. If you don't want to do any calculation, you can do like this. How do you do is modulus of minus z2 is nothing but modulus of minus 1 into z2, which is nothing but modulus of minus 1 multiplied by modulus of z2, right? And the modulus of minus 1 is just positive 1. Then you write down the modulus of z2. Now here, when you write here, there is a point to be noted that this modulus is complex modulus. This modulus is real modulus. Okay. Real modulus means you simply forget about the minus value. That's all. There is nothing more than that. So if at all there is a minus, you simply reject that minus and write down the remaining. That's the meaning of this real modulus. Complex modulus means you take square root of real part square plus imaginary part square. The complex modulus of minus z2 is nothing but complex modulus of plus z2. So that is what I have written here. Of course, that should be trivial. Now take this on the left hand side. Then I can write like this. Modulus of z1 minus modulus of z2. This comes here. Then this less than or equal to, you write down this z1 plus z2. Fine. Now interchange the LHS and RHS. You bring this here and that there. This is z1 plus z2. That would be greater than or equal to this when it goes there, z1 minus z2. And that's it. You got a new relation, and I will call this equation number 5. So what you already have is modulus of Z1 plus Z2 less than or equal to mod Z1 plus mod Z2. This was your equation number 4 from the yesterday's class. Okay. So I am writing this simultaneously because both of them you should keep together. Okay. This is what we got today and this is yesterday. You see that both of them are same, modulus of Z1 plus Z2. Yesterday we derived less than or equal to that. Today we are saying it is greater than or equal to that. What you understand by that is that this is the minimum number and that is the maximum value. Okay, so which means that given this quantity, I can always find the minimum number, that is this, and this is the maxima. So you can always find the lower bound and upper bound depending upon which equation you use. Okay, we got 5, right? So let us obtain some more equation which is looking very similar to that. That we will do. Then let us come back here. So the starting point is that you consider only one number, and then as usual you can subtract and add another complex number. So that is how do you do that is we will consider that modulus of Z1 is nothing but modulus of, I will subtract another complex number, okay, subtract and add the same complex number, then I will be getting this. So now I can write down like this, modulus of Z1 minus Z2, that is my first number. How do you understand this? Z1 minus Z2 is a new complex number. That's what I mean to say. Let us say Z3. So I have Z3 here and Z2 there. So I am applying the triangle inequality and that's what I am doing. Then this plus here, you have this mod Z2. So now what happens, you can now bring this Z2 to the left side. Okay. So then you can get one more new relation, that is Z1. Then you bring this fellow here, the left side, minus Z2. Then you have this less than or equal to. Then you have Z1 minus Z2. Let us interchange the LHS and RHS. Bring this fellow here and that fellow there. And that's it. And now what is this equation number? We say that this is equation number 6. Is it okay? Now what we do is, so that means what? You again got one more relation similar to the triangle inequality, but then there is a minus. That's why it is called the reverse triangle inequality. In what way it is got reversed? Why it is called reverse means actually we are not reversing the triangle. Triangle is as such only. But what is reversed is, in the original triangle inequality you have a plus. Now you have a minus. So it is reverse. In the original triangle inequality you had a less than. Now you have greater than. Therefore it is reverse. Therefore this equation is what is known as the reverse triangle inequality. Okay. But before finalizing this equation, we will also understand one important point, that nothing happens if you interchange Z1 and Z2. So that is a symmetry there. So I will tell you that. So what do you mean by symmetry is, if you write like this, if you invert it, then nothing happens to the left hand side. That means if you interchange, this is the meaning. Okay. If you interchange, that means what? Z1 will be written as Z2, Z2 will be written as Z1. If you write like that, what will happen to equation number 6? That is the question. So what happens to the equation number 6 is, I will write down modulus. 1 becomes 2. 1 becomes 2. 2 becomes 1. Fine. That is called interchanging. Same thing you apply to the right hand side also. And it's greater than or equal to, I will write down that this 1 becomes 2. That 2 becomes 1. Is it okay? So now what you do is you simplify this. How do you simplify? This is nothing but Z1 minus Z2 is greater than or equal to modulus of Z2 minus modulus of Z2. And that's your equation number 6. 6 is over, so I will call this by 7. Here you have to be careful and think here. From here to here, how am I writing? You take a minus 1 outside, I will get this. Therefore, what happens is, the original thing comes back here. The left hand side is original, it came back. But right hand side did not come as original. You see this? The right hand side did not come as original. They are not same. Therefore, what happens is, this is 6 and that is 7. Okay? You have the symmetry on the left hand side, but you don't have the symmetry on the right hand side, what it all means is that this is greater than or equal to. So sometimes, a lot of confusion will come in inequality. How can you have two equations? You ask this question, how can I have two equations where LHS is the same quantity but the RHS is different quantity? How it is possible? The answer is very simple. The answer is the things are greater than. Once you say it is greater than, what I mean to say is it is greater than 3 means if I have some number like 4 or 5, that is also greater than 3. So it doesn't matter. It's greater than means not a single number, right? It can be any number. So that is why this is also true, that is also true. Okay, so it will be, initially it looks like a confusion, but if you put some numbers, then things will be clear. Okay, so now what you do is, now you compare 6 and 7, what you can understand. What you can understand is, since the left hand sides are equal, the right hand side is flipped by a minus, isn't it? This is flipped by a minus, and therefore this minus will be compensated only if you take an absolute value. Otherwise you cannot compensate, isn't it? Therefore what happens is, you have to consolidate 6 and 7 and then write a common equation. That is the conclusion. So I will now write down here. Okay, so how do you write this? We get, so the left hand side is modulus of Z1 minus Z2 is greater than or equal to the big modulus of, you can write down modulus of Z1 minus Z2. And that is your equation number 8. I will call this, so this is the reverse triangle inequality. So equation number 8 is important, and here you have to be clear what is the purpose of the extra modulus coming into picture. The extra modulus will take care of the minus sign that is coming here. Okay, this is 1 minus 2 version, this is 1 minus 2, but that is 2 minus 1. Okay, and the left hand side is same, it didn't change. So therefore what it means to say is, whether it is 7 minus 10 or 10 minus 7, which is correct? That's what the question is. Whether it is 7 minus 10 or 10 minus 7, whatever be the case, if you put a modulus, then the difference is only 3, isn't it? 7 minus 10 is 3, 10 minus 7 also 3, difference is 3 only. Don't worry about this sign. Don't worry about the sign is what is this. That is called a real modulus. Real modulus means don't worry about the sign. You only worry about the difference. So that is the real model. This is real modulus you have. Okay, this line and this line, okay, this line and this line is a real modulus. The two lines here is complex modulus. The two lines here is complex modulus. Okay, so complex modulus, real modulus. This is complex modulus. So you should know what is happening exactly, then things will be clear. So as far as equations are concerned, we have now completed the derivations. Okay, so what are the final equations? The final equations are this. So I will also write down that this is 4. Yesterday we got 4. Today we got 5 and 8. These three equations are the final equations. Okay, the in between we have 6 and 7, but the 6 and 7 is an intermediate steps. Okay, so let us not consider them as a final version. So final version is written here. Okay, so now the conclusion is, if you want to solve any problem, you use 4, 5 and 8. Okay, whatever you want you can use, that is your freedom, but this is the point. Okay, so we are now ready to solve some problems. Okay, but before jumping into the problem, I already told you that this kind of equation, it's looking somewhat confusion. This I can understand easily. Triangle equality, yesterday itself I told that you can draw a triangle, parallelogram, draw a diagonal. That's clear. But what is this one minus here? And this is even more confusing because 2 times modulus is there. So how can I remember? If you try to remember and try to memorize, things will be chaotic, and finally you will write wrong equation finally. So I don't want you to remember like that. But instead I will explain by drawing some diagram, things will be very easy. So I will now explain how to draw a diagram for this. This is clear. How to draw a diagram? This is clear. Okay, triangle and parallelogram. What diagram do you want to draw for this? If you understand this, that equation is also straightforward. Okay, so I am going to draw the diagram for equation number 5, and then you can understand. So I will do that here.